In this video, I'll discuss the importance of hydrogen ions. A water molecule can occasionally break apart into two ions, a hydrogen ion, which is H+, and a hydroxide ion, which is OH-. In pure water, a very small percentage of water molecules are dissociated or broken apart. However, it's very important that we keep track of these because these molecules are very reactive. Hydrogen ions and hydroxide ions are very reactive, so they can have a big impact on biology, such as cells. The concentrations of hydrogen ions and hydroxide ions are equal in pure water, which is considered to be neutral. Let's take a look at how this actually works. We have here H2O, and it can break apart into H plus and then OH. So H plus and then OH minus, which is hydroxide. And you can see the symbol in the middle there. It looks like an equal sign, but it actually indicates that the reaction can go both forward and backward. So it's a reversible reaction. So a water molecule can break apart or dissociate, but the products of that dissociation, the hydrogen ion, the hydroxide ion, can actually come together and reform water. So it goes back and forth. So again, pure water is neutral. Water will break apart occasionally into hydrogen ions and hydroxide ions. Now, when we add in something called an acid, this is going to change the hydrogen ion concentration. An acid is a molecule that donates a hydrogen ion to a solution. So the acid produces what's called an acidic solution. So an example you might be familiar with is vinegar. So if we add some vinegar to water, we'll make the solution of vinegar and water more acidic. And you can see a picture here of what this would look like. So we have our acid shown with an A. It has a hydrogen ion covalently bonded to it. We have this breaking apart, a dissociation, and now we have the acid, which has a negative charge, and then the hydrogen ion, which has a positive charge. Now the opposite of an acid is a base. A base is a molecule that accepts hydrogen ions. So a base produces a basic or alkaline solution. An example would be baking soda, which you can find in just about any kitchen. You add it to water and you will make a basic solution. So let's take a look at how that works. We have our base, and if you have hydrogen ions, and there's always some hydrogen ions in water, they can combine. So it's actually accepting a hydrogen ion, and it's in effect reducing the hydrogen ion concentration of the solution. So you've probably heard the term pH. pH is a scale that expresses hydrogen ion concentration. It ranges from 0 to 14. Pure water at 25 degrees centigrade has a pH of 7. An acidic solution has a pH of less than 7. A basic or alkaline solution has a pH of greater than 7. So the pH scale expresses hydrogen ion concentration. As I said, a change of 1 unit on the pH scale represents a 10-fold change in hydrogen ion concentration. Let's take the example of blood. So your blood pH is actually 7.4, so it's slightly alkaline. But let's just consider it to be 7, just to make it a nice round number. So if we look at our chart here, we see, well, look, human blood has a pH of 7. What does that correspond to in terms of hydrogen ion concentration? Well, that actually means that the hydrogen ion concentration is 10 to the negative 7 moles per liter. So that number 7 actually corresponds to a given hydrogen ion concentration. Now, let's compare this to saliva. Saliva has a pH of 6. That corresponds to a hydrogen ion concentration of 10 to the minus 6 moles per liter. So as we go from 7 to 6, we're going 1 unit on the pH scale, but the hydrogen ion concentration actually changes 10-fold. So it's 10 times greater in saliva compared to human blood. And we could go even further. Let's take black coffee. It has a pH of 5, meaning that the hydrogen ion concentration of black coffee is 10 to the minus 5 moles per liter. That's going to be 100-fold greater than the hydrogen concentration of human blood. Okay, let's take a look at this chart and just look at a few other examples here. What else is acidic? Well, tomatoes are acidic. That's probably not a big surprise. Vinegar is very acidic. It has a pH of, so tomatoes pH about 4, vinegar a pH of about 3, Lemon juice and lime juice are very acidic. They have a pH of about 2. Let's go in the opposite direction. Baking soda, as I mentioned before, it's basic or alkaline. So if you add baking soda to water, you'll end up with a solution with a pH of about 9. Okay, and probably not surprisingly, soap is also basic. And there's a few other cleaners in there, like ammonia cleanser and bleach and so forth. Those are also basic. Now, why are we spending so much time on this? Well, it turns out that pH is incredibly important. In order for you to have a happy and healthy life, the pH has to be very well balanced in your blood and the fluid surrounding your cells and so forth. So any deviations from this value of about 7.4 can be life-threatening. And for this reason, the body actually senses the pH of the blood and maintains the pH in a narrow range around 7.4. And these are topics we're going to hit on more in future videos. But that's it for this video. Thanks for watching.